In this video, I will demonstrate how to join two pieces of aluminum together using alumaweld rods. And for a heat source, I'm going to use a burner on top of an electric oven. I've noticed that a lot of the demonstrations on YouTube in the past, the people seem to have marginal results because they don't get the part hot enough, and they end up using the flame to melt the rod instead of the part. So here I've got two pieces of 6061 T6 aluminum, and I will be screwing them together to keep them in position with these screws, and putting the burner on high, and that brings the temperature up on the aluminum up to around 700 degrees. I've got an 1/8 inch steel plate on here so that the aluminum doesn't actually touch the burner, which could possibly melt the aluminum. But I've tested this and by using the steel plate here, even though the burner is glowing red, the aluminum never gets much over 700 degrees, maybe 720, 730 at the most. So I'll use a butane torch or propane torch to bring the temperature up to the melting point and above the melting point of the rod. I've ground a bevel on both of these pieces so that it forms a notch all the way around for the alumaweld rod to flow into, and I've also sanded it with about a 60 grit sandpaper to get rid of any oxides. So now I'm going to turn the burner onto high and wait a few minutes for it to heat up, and meanwhile I'm going to do some additional sanding on the part. It's just been a couple minutes now, and the part, as you can see, is just up to around 225 degrees or so, and it'll be a few more minutes before it gets up to around 700. Now you can see we're reaching near the melting point. We're around 600 degrees at the point of the weld. In some points on the flange it looks like we're actually over up to 750. I will try to melt the stick on here now, but probably I will add the propane torch to get those last few degrees to get it to flow well. No luck yet in melting the alumaweld. Now it's feeling a little sticky now, but it's not quite melting. There we got a melt. Okay, I'm going to put this down now just a second and see what the actual temperature is reading in here. $728, $790, $780, so it's now comfortably in the melt range. Now, because I've got the burner on, I've got some time to work with this and not have to rush to make sure everything is just the way I want it. Okay, looks great. Now I'm just going to set it over onto a cool plate. Turn off the burner and let it gently cool down. This part is still hot, but it's solidified, and you can see that it has totally, it's got a nice fillet all the way around. I got a little gob that has run out down here, which I'll easily be able to file off when it's cooled down. So I think that this has worked very well, and I'll be able to remove these screws and continue with the finishing of the part.